right, so this is a video showing the PCUI, or Pocket Computer Universal Interface, connected to a TI-92 Plus. And this particular line of calculators would be the calculators that were using the old GraphLink cables. So that would be, the 2.5 millimeter, I believe, is the size. These 3-pin, they look like stereo connectors, kind of. And so those models that were from, I think, the mid to late 90s is probably where these were most popular. These days, most graphing calculators have USB connections on them, so you can easily connect them to a computer. Versus these older ones, you had to buy a special cable that would connect or bridge the GraphLink cable to, say, USB or serial. And those cables, they were a little bit pricey, and I think they still are. If you were to try to find one used, they're a little expensive. But that would let you connect the TI, this generation of graphing calculators to a computer, which again allows you to print the screen, transfer and backup programs. You could even connect two calculators together with one of these cables. And TI provided these cables with the calculator to calculator cable in the box when you bought these new. So they're fairly common for the actual calculator to calculator transfer cables. So again, you can transfer one program or several programs, or back up an entire calculator from one calculator to the next just by connecting them directly together. But for connecting to the computer, historically there's been the need to purchase a specific cable, which is a little bit expensive. But that being said, the Pocket Computer Universal Interface, or PCUI, is this device here, and this is a very early prototype of this particular project. And this project was started primarily to connect older Sharp and Casio pocket computers to printer and cassette interface emulation. So those printers were hard to find, if you can find them at all, and many of them took special ink, pens, paper, etc. So this device will allow those older calculators to connect to a more modern printer, as well as provide some tape storage virtually on an SD card to load and save programs. So this demonstration is showing the PCUI connected to a TI-92 Plus. This will work with all of those similar models that have the same GraphLink connector. So the TI-80, and I could get these models wrong, but the TI-80, 81 maybe, the 83, 85, 86, 89, 92, the 92 Plus, and the Voyage 200. So all of those use the same GraphLink connector, which the other end of this cable is plugged in here. So I have the calculator to calculator cable. These are easy to find, and again, you can find them on Amazon. Any standard stereo or 3-pin 2.5 millimeter to 2.5 millimeter cable will work just fine. So I have this plugged into the TI-Link port on the PCUI, and I have the model set to TI-92 Plus. This would, again, just as easily work with some of those other models that I mentioned. So one of the things that I'll demonstrate first is the ability for the PCUI to save programs and load programs to and from its internal or onboard SD card. So this does not require a computer at all. And the PCUI is intended to be used without a computer, fully functional in that regard. So what I'm going to do now is I'm going to go to the TI-92, and if I remember how to do this, I go to press the second key, go to var link, and then I have all the programs and variables that are stored in this particular unit. And one of the programs I have is Banner, so this is a basic program. And you can see the type of file it is and then the size. So this is a program. You can send expressions and variables, pictures, all sorts of data types from these calculators. So I'm going to go ahead and send the Banner program. And as soon as I press the enter key on the TI-92, it should send. Let's see if we can get this to, let me do that. I pressed the wrong key, I pressed back. So let me press the var link again. I'm going to go, it's hard to do with one hand on the camera here. I don't have an elaborate setup. So I'm going to press F3 instead of the escape key this time, which is link. I'm going to choose send, and then I'm going to press enter. and you could see that the banner program was received by the PCUI and saved to the SD card. Okay, and that program was received, and then this goes back to the same screen here. So I could do the opposite. Now that I have that program on the SD card here, I can go to the send menu, and I have the choice of different types of objects to send, and each one is in a subfolder on that SD card. So for example, if I want to send a program, I select programs, and I have both the banner and the maze program here. So I'm going to go ahead and choose banner, but before I do that, I have to go back to the TI, and I have to go to link, and then choose receive, and press enter. So this is waiting for a file. I'll go back over here, and I will press the OK button. And we can see the TI is saying, do we want to overwrite? I'll say yes. And we have the banner program sent. So we can send programs back and forth, variables, all sorts of pictures and things like that. And again, this is using the SD card here. I'll explain a little bit more about some features for that SD card on the PCUI shortly. So we can send programs, pictures, all sorts of data elements to and from the attached graphing calculator. And we can also put this in a mode that allows for a pass-through. So if I wanted to use the TI software, there's various versions of that TI software, official software from TI for interfacing with these calculators, or the TI linking program, or TILP. If you need, basically need to connect this to one of those programs or wish to do that, you could do that with the use of a GraphLink cable, or a GrayLink cable, I should say, which looks something like this. So you have USB on one side, and then you have the GraphLink cable on the other side. And this is what I was referring to as being a little bit costly these days, or a little bit difficult to find. I don't think they sell them new anymore. So if you wanted to connect your TI to a computer, Windows PC or a Mac, you would have to have that cable. But an alternative would be to use the PCUI for that, and you could enable the GrayLink emulation here. So if I click that button, what that does is enables the USB port. This is connected to my Windows PC, and the PCUI is connected to this TI calculator. So the PCUI in this mode will pass through all the data to and from the TI calculator over the virtual COM port that's in that USB cable there. And so that effectively creates the same exact type of interface that the GrayLink cable would provide, the one over here. That might be a little bit difficult to get these days. So it replaces that. And then I can go into the TI linking software, and I'll just bring that up on the screen here. And I can go to, say, for example, this is the TI Connect software. I could go to the TI Capture, and let's see if we can get this to pop up. Let's close this old screenshot. I'll click no, and then I'll click the capture here, get screen, and it's going from the USB cable in this Windows PC out to the PCUI, and then the PCUI is interfacing with the TI, just passing through those commands and then the data, that kind of thing. And you can grab the screenshot. So the TI software or a TILP or anything else that you are using in terms of software for the TI that would interface through that cable or that style of cable would work perfectly fine as well. So that's just one of the modes that the PCUI supports. So this is great for upgrading firmware, for example. You can do that through the existing software. So that would be the GrayLink feature, and then to turn that off, you just press back here, and then you back to the home screen. And so one of the other features that is useful for the PCUI that's somewhat unique, and I just showed an example where you can use a Windows PC or a Mac to grab a screenshot and print it. While that's not unique and that's been around for a while, the PCUI is intended to be used without a computer. So this is a little bit smaller, it takes a lot less power, doesn't require any software install other than the firmware that's built in. And so this is a kind of maybe an easier alternative to using a PC or a Mac. And one of the features that this can do is print the screen directly from here. So for example, if I hit the print button here, it will grab a screenshot in the exact same way that the TI software does, but it'll grab it directly. It'll display as much as it can on this tiny OLED screen. So in the case of the TI-92, the screen is much bigger than these OLEDs are. So the TI-85 screen fits on here and all of those models and below, but the 92 above, the screen is just too small. So it'll display a corner or a fraction of the screen. And then what it'll do is it'll save it as a PNG file onto the SD card. And then it will direct the output to the attached printer. So in this case, I have a serial connection here connected to an Epson thermal printer here. And these are very inexpensive on the used market. The paper is really, really cheap, inexpensive. So these are great printers for small printouts and quick printouts, that kind of thing. You don't need any ink because it's thermal, so no inkjet supplies, no ribbons. I do have an old dot matrix printer I've tested this on, this PCUI, but this is the fastest, cheapest solution in the modern day. There is a parallel port also on the PCUI, so you can connect this to parallel printers or serial printers at the moment. And you direct that setting through the menu system here. So I have it connected to a serial port. So as soon as I hit print, it's going to grab the current screen. And there's a progress bar. It's going to be tough to see with the waviness and the refresh rate here. Normally you don't see that, but on the camera it's interacting in a certain way. So there is a progress bar. It's sending that data to the printer as an image. And then the printer itself is receiving that over the serial port. And as soon as it's done, it'll print that out all at once. And then we issue a paper cut command. And then that's the printout. So that is using the Epson ESC POS protocol, or character set or control code sequences. So the way that works is you initiate a data transfer or image transfer. You send the bits to the printer, and then when you're done, it prints the entire image all at once. And there's actually no lines, no vertical lines in there. Some of the other modes I was experimenting with, printing graphics with, say, 0 for line spacing, there's still a slight line in there, but I was able to get this to print without any vertical or horizontal bars, I should say. But the paper or the printout is transposed. So if I had printed it this way, the screen would have been much smaller on the printout, which is an option. In the menu, you can print it not transposed, and you can change the scaling. So this is scaled, I think, at 2x, or no, this is scaled at 8x. So this can print very, very small images. It's a fairly high resolution printer, but this is 8x scaling, and I have the transpose turned on, so you get a wider printout. So again, whatever's on the screen, hit the print button and it will print what's on the screen. It'll also save it to a PNG file on the SD card. So the PCUI definitely can, as we see here, provide printer connectivity directly to the attached TI. One of the other features that I've added is, although these TI models of graphing calculators did not officially support any printer of any kind that I'm aware of, other than going through a PC or a Mac through the GraphLink cable, you can print the screen. What I've done, and a lot of the interesting ways I experiment with all of these older calculators, is to write a banner program, for example, just to familiarize myself with how they work and how their printers work. And one of the things I did on the TI is provide programming support, kind of in an interesting hack that will allow me in a basic program, to print through the PCUI to the attached printer. And keeping in mind that this didn't really support and doesn't really support directly the ability to print. And the way I do that is in my program, I will see if I could pull it up, just show an example here. I'll go to the program editor, I'll open the banner program, for example, and we can see, I'll give an example here, where I'm setting a variable here, the ESC POS. This is kind of an interesting basic dialogue on these TIs. I'm used to saying, A equals 5, B equals 6. In this case, with the TI, it's the value with an arrow, so true, and being set to this POS, ESC POS variable. I made that variable name up. And by saying that that's true and setting that variable to true, I can then use a function in BASIC here that the TI supports called sendCalc. And what that does is it sends a variable. In this case, I made a variable called print. That's just the name of the variable. SendCalc print will actually send that variable to another calculator. Well, in this case, I actually have it connected to the PCUI. So the PCUI is going to receive that variable, and it's going to look at the name of the variable, and if it's a certain name that we're expecting to see, like print or ESCPOS for turning on special graphics mode on this, or any other various sorts of settings, the PCUI will interpret that. And then in case of a print, it will simply take the variable contents and send it to the printer. So that's how we're going to, I'll call it a creative hack for getting printer support. So let's see how this works. I'll go ahead and exit that screen. And I called the program Banner, which you saw earlier. I actually sent that to the PCUI and saved it. So I'm going to type Banner, and this is kind of interesting on these TIs. You have to go to the character mode menu here to get a quote. And then I can say PCUI. I'll go back to the character menu here to get the quote. Okay, so as soon as I hit enter, what's going to happen is it's going to try to print PCUI in a big banner format over to the printer. So I'll go ahead and press enter, and I'll try to get that on camera as it's printing. So we can print from the TI directly to the attached printer. Again, I'm showing this on an inexpensive thermal printer, but I've actually done this on an old dot matrix printer. Unfortunately, it uses a lot of the ribbon, and those ribbons are, they don't last very long. So anyway, this doesn't require any ink or ribbons. And you can see a little bit of the vertical bars that appear here from the line gaps, but it's as good as it can get on these inexpensive printers in this non-graphics mode. This is actually a character mode. So we can easily print from here in BASIC and not just print the screen, although printing the screen is useful for printing graphs and things like that, but it can also print other things. So you can print text, data, pictures, whatever is interesting or needed there. And one of the other uses, I also sometimes experiment with, and you've seen probably some of my other program examples. I call it the maze program, so I'm going to go ahead and give a demonstration of that. So it's just another basic program. And so I'm going to try 7 pixels by, I don't want to waste too much time in this video. Actually, we'll do 15. That's a good round number. So 15 pixels wide by 15 pixels high. I'll press enter, and the program will run. This is kind of small. It will draw the maze randomly on that canvas, which is 15 by 15. Again, this is a basic program. And then when it's done, in the basic program, we're going to tell the PCUI to grab a screenshot or screen print, but only print the 15 by 15 area here and scale that up. And this is all done in BASIC. So we're telling the PCUI what area of the screen to print and the scaling factor. And then when it's done, it should print it. We can see that screen print is happening and the maze is printed. And so we have a 15 by 15 randomly generated maze. I've actually, just out of curiosity to see how long it would take this to draw the full screen. It takes a long time to draw, but it does it, and we can print it out here. It just takes way too long. So that's an example of the maze program. So the PCUI here, this was, again, a very early prototype. This supports many more models by the time this video is posted, various Casio and Sharp models of vintage computers, pocket computers. But for the purposes of this demo, this is just showing the proof of concept of getting the printer working, the PNG support, the SD card support, the parallel serial interface, scaling, the menu system, just making sure that a lot of the basics of the user interface and menu system work well. And I'll just give a quick demo of that. So let's say we don't want to use the TI-92. We could unplug the TI-92. We'll put that away for a minute. And then we'll grab a TI Voyage 200, and I will try to plug this in on camera here with one hand. Okay. And we have the Voyage 200 plugged in. And then I can go in here and go to settings. We're going to go to calculator model, and we're going to switch that to, these other modes are not fully baked yet. So we'll go to Voyage 200, we'll press back. So now we're on the home screen and it's indicating Voyage 200. Again, very similar to the TI-92 in terms of functionality, almost identical. Except this model has a great home screen. So this has a lot more flash capacity and more like a PDA type interface on the front. It's basically the same though from that point forward. So you can select the home screen to get back to the familiar screen we saw earlier like this to run the programs. We could also get the program editor. So it's very similar. And so now that I've selected Voyage 200, for example, I can go in here and say print screen, and it'll grab the screen. Again, you can only see pretty much a quarter of the screen, if that, on the small OLED here. But it's sending it to the printer. And then I'll pan over to the printer here and we'll see that print out. So again, it sends the whole image, which is what takes a few seconds. And then the printout is done. And you can see the home screen of the Voyage 200. So that is a quick demonstration of the PCUI with the TI graphing calculator support. Again, for the older models that had the GraphLink connector here, some basic support. And this, pardon the appearance, but this is, I don't have a charging circuit on here for this, and this is my power coming into the board. And so it's a little bit wired up for debug here, and I have a debug cable and another Pico here, but this is work in progress. By the time the video is posted, there'll be much more support for some of those other older, more vintage models. But anyhow, I will post a link to this project in the description, and you can find relevant information from that link. Thanks for watching.